So a function of a variable x is denoted by f of x. So where does that f come from? The f comes from, you know, function and x. So we have f of x. So the parentheses simply means of. So that notation is function of x. So if we recall in the previous video, we had a bunch of equations. So when we write an equation, for instance, y equals 3x minus 4. Now we have one part oh boy. So that 3x minus 4 is on the right-hand side. So all of y depends on everything on the right-hand side. So here, that right-hand side is what we call a function, and it has x in it. So here, y is a function of x. That is, y is equal to f of x. So in this problem, f of x is simply 3x minus 4. All I'm doing is I'm comparing the right-hand sides. So f of x is directly equal to 3x minus 4. Going back to the concept of a relation, if you look at this equation, all of the left-hand side, which is just y, depends on everything on the right-hand side, which is 3x minus 4, and 3x minus 4 contains the term x, so y depends on x. So if y is a function of x, then y depends on x. And that's what the equal sign means. So write that as a remark. And clearly, what do we mean by depends on x? This simply means so if something is dependent on something else, one is going to affect the other. And that's exactly what we mean by dependence. So if I keep on changing the values of x, it is going to affect the values of y. But a relationship, a relation would also mean the same thing. So a function and a relation are, you know, the same, but mathematically, for us to say a relation is in fact a function, it has to satisfy the pictures that we drew in the previous video. For a single value of x, there is only a single value of y. Some people might find it harder to draw the ovals and, you know, put the arrows from one side to the other. So we have a simple test called a vertical line test. What is the purpose? The purpose of a vertical line test is to determine if a relation is a function. So if we want to determine if a relation is a function, we can simply use the vertical line test. So obviously, it's called a vertical line test, so it must have a vertical line. So how do we do this? So we have to draw a vertical line through the graph of a function. I would say relation. And if the vertical line touches more than one point in the graph, then the relation is not a function. And in mathematics, most of the things that we do just involve functions. In geometry and such, we have relations that are not functions, but in practice, about 70% of the studies involve functions. So here I have a graph. And how did I get this graph? Well, there was a function that produced this graph. So I know what the function is in this particular problem. This is the function y is equal to x squared. But you don't have to know that at this moment. We want to find the domain and range of these functions, and we want to see if the relation is in fact a function or not. So before starting and getting to the concept of domain and range, so what we've done here is we drew 3 vertical lines, then we identified the domain and the range. The domain would be all real numbers, the range all positive real numbers, and 0, because 0 is neither positive nor negative. And we came to the conclusion that the range would be all positive real numbers because we saw nothing over here. There is no curve defined here, and the entire curve is defined only in the positive side. So how do we determine if something is a function or not? So I can show it by moving this vertical line, and I'll bring it back. So as I move this vertical line throughout the domain of the function, so for every single value of x, no matter where I move this vertical line, it touches the curve exactly at one point. So any vertical line drawn through the curve, which is in blue, will touch or touches It touches the curve at exactly 1 point, so it passes the vertical line test. So if it passes the vertical line test, then the relation is a function. The curve corresponds to a function. Now, moving on, we have a funny looking curve here. The curve is in blue. I'm going to draw a vertical line, a bunch of them. Let me draw one here. Oops. One there, and another one there. And you can see the vertical line touches the curve at more than 1 point. So this curve cannot be a function. But we have to look at the entire domain of the function in the previous case. But in this case, if it fails at 1 point, and that's all we need, if a relation doesn't satisfy the condition for a function, even at one single point, then that relation cannot be a function. So here, got a whole bunch of vertical lines that fail the vertical line test. So what is the domain here? If you look at the x-axis or the curve is only defined between -1, which is right over here. So -1, that's where the curve ends, and it goes all the way up to +1. So the curve is only defined between -1 and +1. So I can conclude that the domain is the set of all x values between -1 and 1, including -1 and +1. You might remember a set notation from high school or middle school. So all values of x satisfying -1 less than or equal to x less than or equal to 1. And that would be the domain. Now, the range would be the set of all y values for which the function is defined. So the function keeps on going in the positive side. So it keeps on going, it's wiggling, and it keeps on going upward. And likewise, it keeps on going downward. So every single value on the y-axis will be covered in the positive side. Every single value on the negative axis of y is also covered. So the range is from -infinity to +infinity. So it would simply be all real numbers. Now, in the previous problem, I moved that vertical line back and forth to indicate that the vertical line test is satisfied at every single point of the domain. Here, if it fails at 1 point, that's it. The relation is not a function. Here we have 3 vertical lines that fail the vertical line test. So this is not a function. the vertical line test fails, which would mean that the curve is not a function. It is the same as saying the relation is not a function. And the curve is in blue. I will put a remark here before I move on. So the remark, if a relation fails vertical line test at one point, I'll just say once, it is sufficient to conclude that the relation is not a function. But to conclude if something is a function, you should make sure that the vertical line test is satisfied for all x values in the domain of the relation. So the second remark is to conclude so going back, again, if I move that line back and forth, every single value, for every single value of x, the vertical line would only touch the curve exactly at one point. So that is a function. But that is not the case here. It failed at one point, so automatically that cannot be a function. And that's what this remark means. So here we have another curve. Here we've got two curves. It doesn't matter how many curves you have. I know from experience that this just corresponds to one function, but that doesn't matter. All we have to know is if this is a function or not. So we have a relation. The blue curve connects x and y. So the curves represent relations. But are they, or do they correspond to a function? The answer is no. All I have to do is draw one line right there, and that one line crosses the blue curve at 2 points. Oops, wrong choice of colors. And crosses the blue curve at 2 points. So naturally, this particular relation is not a function. So the curve is going, it keeps on going. That's what the arrow means. So it keeps on going over here, over there, and same, it keeps on going. So the lowest value, x value that we have is at 2. So the curve keeps on going for 2 and above. and -2 and below. There is nothing between -2 and 2. So you don't see a curve between those 2 points. So there is nothing here. So the x values cannot include numbers between -2 and 2. So the domain would be x greater than or equal to 2, 2 or more, or x is less than or equal to -2, -2 or less. So all of these values, all of those values are okay for x. The range, on the other hand, is every single number that we can think of. So there is a value there for y, value for y, value for y, value for y, and the same here. So all of positive y values are included, all of negative y values are included, 0 is included for y, so the range would be all real numbers. And last but not least, this is tricky. I mean, some of you could look at this and immediately recognize that this is not a function. But there is only one curve. And if I drew a vertical line through a vertical line, it is going to touch that curve or vertical line at infinitely many points. To illustrate, hopefully I can draw one. So I'm drawing a vertical line through the actual curve, which is in blue. So you can see that the red line touches the blue line at every single possible point. So a vertical line through a curve, which is a vertical line, will most certainly fail the vertical line test. It's so obvious. If you drew a vertical line through a vertical line, it is going to touch at every single point. So it is going to fail the vertical line test. So the relation is not a function. But how do we define the domain? The domain is the set of all x values for which the curve is defined. If you look at it, the curve, the blue curve that we started with, is defined only for x is equal to -2. So that is the domain, because there are no other values, nothing over here. I don't see a curve for x values over there. I don't see a curve for x values over there. So the domain is just x is equal to -2. The range, on the other hand, every single value, if you draw lines from the blue curve that we had to the y-axis, everything is covered. There is a curve for every possible y value. There is a curve over there initially. Now it's in red. So it keeps on going. So we've covered all of positive values. We've covered all of negative y values. We've covered 0. 0 is right over there. So the range would be all real numbers. And that is how we determine if something is a relation, a function or not.